So probably the foremost question on your mind still is right at the top of this screen, why are we even doing this? Okay, it doesn't seem to be very efficient at finding the answer. It seems to be just probably about as much work as doing it by hand by using regular elimination. And there's tons and tons of opportunities for simple arithmetic mistakes. So yeah, again, why the heck are we doing this? Especially since we learned a couple of easier ways, like faster ways. But if we're going to rely on a computer to do this for us, like our calculator, it can do those operations very quickly. It says is quicker than you can say augmented matrix. Here, the benefit is that you only have one matrix to input into your calculator, and that's going to be quicker than doing it by, say, inverses. Inverses, I had to put two different matrices in there, multiply take the inverse of the first one and multiply it times the second one in order to get the answer. Okay. If I did it with Cramer's rule, I had to put the coefficient matrix in, find its determinant. Then I had to change the coefficient matrix and find its determinant and divide those. So the inverse method was a little bit faster, and you're going to see on your calculator that this is the fastest of them all. But I wanted to lay the foundation so that you understand exactly what it is that a computer or a calculator is doing whenever you do this row-reduced echelon form, RREF. So again, this is on a calculator. I go back to the same math screen underneath the matrix menu, and this time I'm going to choose RREF, which stands for row reduced echelon form. That's exactly what we want. It's going to go straight to the answer. Okay, so let's try that on this one. I'm going to solve it using an augmented matrix. I'm not going to even write anything down. I'm just going to pull up the calculator. I'm just going to pull it right up, and I'll put everything in there. I'm going to solve it. It's a matter of seconds. Okay. All right. Let's clear this out. Let's go to the matrix menu. I'm going to go over here to edit. Let's edit A as a 3x4, of course. Okay, and then just type in your equation with just the coefficients like you see them.
4, a 1, meh, -3, a 19. Okay, so there's the first row in. Type in your second equation, a -2, a 2, a -1, and a 12. Okay, and then the last row, a 1, a 1, a -1, come on, and 39. Since we're relying upon the calculator to do everything for us at this point, make sure that you did not commit any typos. Let's see. And alright, so that looks fine.
Okay, so I'm going to quit out of this, and I'm going to go back to the matrix menu and scroll over to math. Now I can choose to either scroll down until I get to B, or I can choose alpha B. I can push that on the actual keyboard, and it would just pull up the RREF. Inside the parentheses, we need to put the name of matrix A. So back to the matrix menu, choose A, hit enter, and there's your answer. That quickly. Only had to put in one matrix, only had to do one operation on it, and it's done. My answer is X is equal to 30.4, Y is equal to 64.2, my Z is equal to 55.6, and I'm done. Okay, so I would like for you to try same thing on this 4-variable system. Right? It might seem intimidating until you put it into the calculator and it spits out your answer in a matter of seconds. So go ahead and pause the video, input that thing, and let's see what you come up with. Alright, so let me pull up the calculator here so we can take a look at the answer. So I have it inputted there. Of course, you want to make sure you don't have any typos. What size matrix did you have to do? Well, it's going to be 4 rows by 5 columns. It's a 4 by 5. When I do row reduce echelon form on it, here's my final answer. A is equal to 2, B is equal to 14, C is equal to 3, and my D is equal to nothing, to 0. Okay? That's it. See how fast that was and how easy it was? This is the best method. It's the best method to solve a system of equations, especially really, really large systems. Okay? Now, here's the no solution case, and I want you to actually put this in the calculator, and I want you to see what happens when you put this into the calculator. So of course we need to put that 3x3 system in an augmented matrix and do row reduce echelon form on it. So go ahead and pause if you need to, type that thing in, and then unpause it. Okay, whenever you hit enter on your calculator, this is what you should come up with. Okay, so the top row looks fine, but it doesn't have like the form of the identity matrix on the left hand side. And if I look at the middle row right there, I have 0, 0, 0, 1. That is a contradiction, because what it's saying is 0x plus 0y plus 0z is equal to 1. In other words, 0 is equal to 1. If at any time I put one of these things into an augmented matrix and do row reduced echelon form and I get a contradiction like that, I know there's no solution. This is kind of nice. This is different from the other two methods that didn't distinguish between no solution and infinitely many solution. Okay, so it just said, like, if the determinant of the coefficient matrix was 0, all it said was maybe it's no solution, maybe it's infinitely many solutions. Okay, so this one is superior in that form. So now let's look at the infinitely many case. Okay, so type in this in an augmented matrix and do the row reduce echelon form on it, RREF. Pause the video if you need to so you can type that in. I want you to see what happens on your calculator. Okay, so this is what we should get this time. So look at the bottom row. The bottom row is not a contradiction. This time it's saying 0x plus 0y plus 0z is equal to 0, which is a true statement. It's an identity. So this indicates that we have infinitely many solutions. And the stuff that's right up above them, that's going to help us write our answer in a generic order triple in terms of A. So let's take a look at that, right? So I'm just going to rewrite that matrix on this next slide right up here. And let's rewrite this as an order triple in terms of A. We're going to start with this middle equation. So this middle equation basically says there's no x, but y minus 1/3 z is equal to 5/3. Okay. At this point, I need to pick either y or z to be my A. Okay, and then I'm going to rewrite everything else in terms of that. Okay, so let's choose y is equal to A. I'm going to plug that right in there. And you're going to see why I'm going to choose that one in just a second. Okay, so when I do that, I'm going to get A. That's an arrow. No, it doesn't look like it, but it is. Now, that's a more official looking arrow. Minus 1/3 z is equal to 5/3. Now we need to solve this thing for z. So to solve it for z, I'm going to subtract the a over. So negative 1/3 z is equal to 5/3 minus a. Now I'm going to multiply everything by negative 3. Okay, when I do that, I get z on the left-hand side. 5/3 times negative 3 is a minus 5. And negative 3a times negative 3 is a positive 3a. So I'm just going to switch that around and make that 3a minus 5. Okay? So now I have my y-coordinate as a, my z-coordinate is 3a minus 5. Now if I had chosen, let's say I chose z to be a. Let me switch colors here. If I put a in for z, y is equal to, well, not equal to, minus 1/3 of a is equal to 5/3, then you'd be solving it for y, and you just add the 1/3 over, and you have y is equal to 1/3 a plus 5/3, right? And you have fractions in that one. Not that it's bad, but look at this bottom one down here that we got before. It's going to be far easier to substitute in order to find what x is. Okay, so keep that in mind whenever you go to do your substitution. One of them might be easier than the other one. So now we're going to take both of those and we're going to put it into the top equation so we can find out what x is in terms of a. So the top equation is x minus 1/3 of that one right there, which is 3a minus 5. That's all equal to negative 28/3. Okay, so now let's distribute here. And I have x minus, just minus a, because the 1/3 and 3 will cancel. And then plus 5/3 is equal to negative 28/3. Okay, so let's subtract the 5/3 over minus 5/3. So x minus a is equal to, up top I'm going to have a negative 33/3, which is just negative 11. And then finally add the a over, so x is equal to a minus 11. Your final answer then, in terms of a, is a minus 11, comma, a, comma, 3a minus 5. So you can see that the augmented matrix doing row reduced echelon form helps you out in all kinds of ways. Finding out what the solution is if there's one, even telling you if there's no solution or infinitely many, and the matrix that you get whenever it's infinitely many helps you write the final answer in terms of A really easily. Okay, so that concludes our final lesson for this unit, being able to solve a linear system by putting in a triangular form. You can see the guy making a triangle with his hands. Okay, perform elementary row operations on an augmented matrix, which means that we can interchange two rows, we can multiply any row by a non-zero constant, and we can add a multiple of one row to another row to replace that row. And then finally, putting it all together to solve a linear system of equations using an augmented matrix in the calculator that's row reduced echelon form, and it does it really quickly. It's very, very nice. So here is your final assignment here. And when we do this in class, what I had to do, since there was no section, is just go to other parts of the book, find some systems of equations, and the answers will be ones that I've worked out for you, so you can see exactly what you're supposed to do with these new instructions here. And again, now you have definitely enough information to start looking at that cryptography part of your test, okay, because it involves some row operations to come up with your matrix. Okay, see you in class.